Welcome again, Wildcats. All right, so today we're looking at Thursday, October 12th, solve 3x3 systems algebraically, and that's going to be on page 19. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, solve 3x3 systems on page 19, okay? And let me set it over. There we go. All right, step 1, number the equations 1, 2, and 3. Step 2, eliminate the same variable from 1, 2, 1 and 3, or 2 and 3. Step 3, number these equations 4 and 5. Step 4, now solve equations 4 and 5. Select pause there so you can update that. All right, now let's look at step 5. Plug the variable back into 4 or 5 to get the other variable. Step 6, take the two variables and plug into 1, 2, or 3. And then step 7, state the solution. All right, so if you would finish up those notes. All right, now your notes updated. Let's take a look at our examples. Now, take a deep breath. This is going to be pretty intense. This is solving a system with a 3x3 system, okay? Now, I'm going to go over example 1 and 2 in the video, but understand, because I know it's so intense and there's so much going on, that if you like, I'll go over example 1 and 2 in class again as well, okay? All right, so let's look at example 1. All right, so step 1 says number the equation. So let's number 1, 2, 3. Okay. Now, step 2 says eliminate the same variable 1 and 2, 1 and 3, or 2 and 3. Well, I'm going to eliminate the y because I see the 2y and the negative 2y. So in step 2, I'm going to actually use equations 2 and 3. Actually, no, 1 and 2. I'm sorry, 1 and 2. So, and I'm going to put a 1 in front of the x. So 1 plus x plus 2y minus 3z equals negative 2. Oh, just a bell, sorry. And then again, I'm using 1 and 2, okay, because of the 2y and the negative 2y. Okay, so then that's 2x minus 2y plus 1z equals 7. All right, so you can see here that the y's cancel. So then we have 3x, negative 3z, and 1z is negative 2z. And then negative 2 and 7 is 5. So that now is equation 4. Okay. Now we're going to use two and 3, but we're going to have to multiply 3 by 2. Okay. So we're going to use equation 2, which is 2x minus 2y plus 1z equals 7. And we're going to use equation 3. Remember, we're having to eliminate the same variable from both, and we're going to use y. But I know if I multiply this by 2, then these will cancel, but I have to multiply everything by 2. So the new 3 is multiply 1 by 2, 1 by 2, 2 by 2, and negative 4 by 2. So I get 1 by 2 is 2x, 1y is 2y, 2 times 2z is 4z, and 2 times negative 4 is a negative 8. Now, the y's eliminate. Remember, when you do this, you have to eliminate the same variable from both, okay? And the reason why is this. You'll have 4x plus 5z equals negative 1. So if you do that, now the 4 and 5 have the same variables, in this case, x and z. So this is the equation 5. All right, so that was step 3 and 4. We've numbered the new equations 4 and 5. Now we're going to take those equations. So I think that's my phone, but this is more important right now, so I'll answer that later. Okay, so 3x minus 2z equals 5. That's equation 4. And 4x plus 5z equals negative 1. That's equation 5. All right, now here's the thing. We can't eliminate x or z, but we see the negative, and that's where you want to look for your elimination. So I see the negative 2 and 5. So if I multiply the first equation by positive 5 and the second equation by positive 2, that will give me a negative 10 and a positive 10, and they'll eliminate. So that's what we're going to do. Okay, so 5 times 3x is 15x. 5 times negative 2 is negative 10z. And then 5 times 5 is 25. And then 2 times 4x is 8x. 2 times 5 is 10z. 2 times negative 1 equals negative 2. Now the z's will cancel. Okay, so 15x and 8x is 23x. Those cancel. You get equals 25 minus 2 is 23. All right, so you divide 23 by both sides. X equals 1. All right, now we're into step 5. Plug variable back into 4 or 5 to get the other variable. So I'm going to go back to the original 4 and 5, which is here. Okay, what's in the parentheses. Now, it really doesn't matter. I'm just going to plug. I always go back into the first one, but you can plug in the second one as well. But I'm going to plug in 1 into the first equation, or into equation 4. So that's 3. Again, we're using this as equation 4. Okay, so this is 3 times 1 minus 2 times z equals 5. Well, we know that 3 times 1 is 3. Okay, so we just know that's 3. Now we're going to subtract 3 from both sides. So you get negative 2z equals 2. So I kind of did 2 steps there. And again, in class, I can always fill in those 2 steps if you like. Okay. Now here, I'm going to divide negative 2 by both sides. So z equals negative 1. Okay, so at this point you have 2 variables. Now in step 6, we're going to take those 2 variables and plug it into either equation 1, 2, or 3 to find the third variable. I'm going to go back to the first equation because it looks the most simple. Actually, no, I'm actually going to plug it into the third, and this is why. Because here, that's an x and a y. There's less going on in 3, okay? So now I'm going to take equation 3, and I'll plug those numbers in, okay? So that's 1 plus y plus 2 times z, which is negative 1, and that equals negative 4. So then I get 1 plus y minus 2 equals negative 4. You didn't see that, but I just made the shot, the pencil shot from here. That must have been like 8-foot shot. Should have got it on camera. All right. So then combined terms, 1 and negative 2 is negative 1. So you get y minus 1 equals negative 4. Okay. So then I'm going to add 1 to both sides. I get y equals negative 3. All right, so now you have your solution. X is 1, y is negative 3, z is negative 1. You don't want to put your solution at the bottom of the page. You want to move that up to the top. So your solution is 1 comma negative 3 comma negative 1. Wow, all that for 3 numbers. So much fun. That was awesome. All right, so now let's look at example 2. All right, so step 1, number the equations 1, 2, and 3. Now, in the first one I did like little line dash. You can also do circles when you number them. Okay, so it's equation 1, 2, and 3. All right, and so it looks like I want to use 1 and 3 first because of the negative 2y and the 2y. Okay, so we're going to use equation 1, 4x minus 2y plus 4z equals 8. And then 3, which is negative 2x plus 2y minus 6z equals 4. And the reason why I picked 1 and 3 because the y's cancel. Okay, so then you get 2x, that cancels. You get 4z and minus 6z is minus 2z equals 12. So now that's equation 4. All right, so now let's use equations 1 and 2. And the reason, again, is because I'm using negative. Now I have to get rid of the y, so I'm going to have to multiply the second equation by 2. So that's 4x minus 2y plus 4z equals 8. And then 2. Now I'm going to have to multiply everything by 2. Okay? So 2 times negative 3 is negative 6x. 2 times 1y is 2y. And then 2 times negative z is a negative 2z equals 2 times negative 4 is negative 8. All right, so 4x minus 6z is negative 2x. Y's cancel. You get 4z minus 2z is a plus 2z. And then 8 minus 8 is 0. So now that's equation 5. All right, so now step 4 is, so now we're into step 4. Now solve equations 4 and 5. So here we have 2x minus 2z equals 12. Negative 2x plus 2z equals 0. All right. Now you'll notice the x's cancel, the z's cancel. So that cancels. You get 0. 12 and 0 is 12. You're left with a false statement. If they're ever true, you eliminate both variables and you're left with a false statement, then you know that there is no solution. All right, so that gets you set up for Thursday, October 12th. At this point, if you want to go and start working on the problems, you can. If you want to wait, you're like, whoa, it's a lot to take in. I want to wait till Mr. Luke goes over example 1 or 2 in class. Start assignment by all means, but at that point, that's kind of where you're at your decisions, okay? Hopefully you had fun with that. That was, I think, some Wildcat math fun. And now have a wonderful Wildcat day.